Yeah, good evening everyone. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Yeah, today we are going to discuss about the factor theorem. So previously we discussed about the remainder theorem. So what is the remainder theorem? If p of x is a polynomial which degree is greater than or equals to 1 and a is any real number, if p of x is divided by x minus a, then the remainder is p of a. Then the remainder is p of a. That means here you have to understand that if you are taking any polynomial, it must be greater than or equals to 1. Its degree must be greater than or equals to 1. Same way, coming to the factor theorem, if f of x be a polynomial of degree greater than or equals to 1, and a can be any real number, if x minus a is a factor of f of x, and we need to show that f of a equals to 0. So from this we can write, if f of x is divided by x minus a, it will give some remainder. Am I right? At the same time, it will give a quotient also. That means x minus a linear polynomial into quotient q of x plus remainder is r of x. And that too, from the first case it is given that x minus a is factor. X minus a is factor means it is exactly divides the polynomial without leaving any remainder. It is exactly divides the polynomial without leaving any remainder. That means the remainder becomes 0. The remainder becomes 0. So from this we can say that f of x equals to x minus a into q of x. What is q of x here? Q of x means quotient. Okay, na? Yeah. Then we need to prove that f of a equals 0. Let us substitute a value in this equation. Then it will be f of a equals to, that means in the place of x, we need to substitute the real number a. So a minus a into q of x. What is the a minus a? A minus a is nothing but 0. So 0 into quotient. 0 into any number is 0. So from this we can prove that f of a equals to 0. Simply, factor theorem is, if you take any polynomial whose degree is greater than or equals to 1 and a will be any real number, then f of x is divided by x minus a, f of a equals to 0. When it is possible, if x minus a is factor of the polynomial f of x. Factor means it is not leaving any remainder when you divide with x minus a. Okay, na? Same way, if f of a equals to 0, then x minus a will be the factor. Let us see this. So that's why I recall again remainder theorem. What is the remainder theorem? If f of x is divided with x minus a, then the remainder is f of a. Am I right? Then the remainder is f of a. Here f of a becomes 0. F of a becomes 0. That means while you are substituting here f of a 0 means x minus a will be the factor for the given polynomial f of x. Okay, na? So these two are vice versa. If x minus a is factor, f of a becomes 0. At the same time, if f of a value becomes 0, then we can consider that x minus a is a factor. Same way, f of minus a is becomes 0, then what will be the factor? X plus a will be the factor. Okay, no? F of a 0 means x minus a factor. F of minus a is 0, then we have to take x plus a is a factor. Same way, f of 1 is 0. Then what is the factor? X minus 1 will be the factor of the given polynomial. Okay. f of minus 5 is 0 here. Yeah, in this case, x plus 5 will be the factor. Got it now? Right. So this is about the factor theorem. So let us check the factorization of a polynomial whose degree 3. Here one of the example I have taken, that is x cube plus 13x square plus 31x minus 45. So its degree is 3, so nothing but it is a cubic polynomial. So as we discussed that, according to the degree, we can identify the roots. Roots are solutions. If a polynomial having the degree 3, it will definitely have 3 roots or 3 solutions. Same way, degree n polynomial, there are n possible solutions. Okay, na? Yeah. So that means for this cubic equation, we need to find 3 solutions. Okay. But until then, we discussed that remainder theorem and factor theorem. If a polynomial divided by x minus a or x plus a, one of the linear polynomial, that means the given polynomial should be divided by a polynomial, then we have decided it is a factor or not. But here we got only the polynomial, we did not get any linear polynomial or quadratic polynomial here. Then what to do? Here, how to find the factors of a cubic polynomial. Okay, but quadratic polynomial, we have 3 different type of methods. What is that? We can use the quadratic formula. What is that? Minus b plus or minus square root of b square minus 4ac by 2a. Or we can splitting the middle term or completing square method. So 3 different methods are there for identify the roots or solutions of a quadratic equation or a polynomial. What? But here cubic polynomial, no? From this cubic polynomial, what is the constant term? Here the constant term is minus 45. That means if you take cubic polynomial or biquadratic polynomial, first of all we need to identify the constant term. Here constant term is 45. Let us write all the possible factors of 45. All the possible factors of 45. From here, 1 is the factor for every number, right? So 1 into 45 is the first pair of possible factors. Next 3 15s, 5 9s. So here there are 6 factors, 6 positive factors I am finding, but we need to check each and every factor by substituting in the given polynomial. Okay, so by using the factor theorem, let us identify the factors for this cubic polynomial. So here we need to, I am going to introduce the synthetic division also. Okay, so before that, for cubic polynomial having maximum 3 roots, we need to identify any one of the root by taking the factors of the constant term. What is the constant term here? 45. Let us write the factors here. So 1 into 45 and 3 15s, 5 9s. So there are 6 factors with plus or minus symbol, total 12 factors we have. We need to substitute one by one for getting the one of the factor, then we can use synthetic division to identify the remaining 2 factors. Okay, let us see. Now I am taking this given cubic polynomial as f of x. So f of x is equals to x cube plus 13x square plus 31x minus 45. Now I am going to substitute 1 and minus 1 in the given polynomial. So if the polynomial value, that means f of 1 or f of minus 1 value becomes 0, then x minus 1, x plus 1 becomes factors to this polynomial respectively. Let us find f of 1. So substitute 1 value in the place of x. So 1 cube and 13 into 1 square plus 31 into 1 minus 45. 1 cube value is 1 itself. and 13 into 1 square is 13, and 31 into 1 is 31. So add all the positive values, I am getting 45 and minus 45. So 45 minus 45 becomes 0. That means f of 1 is 0. So according to the formula of factor theorem, f of a becomes 0, x minus a is factor. Same way f of 1 is 0, then x minus 1 is factor here. Okay, na? So if you identify one of the factor of this cubic polynomial, by using the synthetic division, we can easily identify the remaining two. Or else, you substitute all these 1, 3, 5, 9, all these factors in f of x, you will get the required polynomials, okay, required factors. Then we can write the cubic polynomial as product of 3 factors. Okay, so let us see the synthetic division. For doing the synthetic division, we need to write the coefficients of the variables and the constant term as well. What is the coefficient of x cube? Coefficient of x cube is 1. And second term is x square term. Its coefficient is 13. Third term is x term and its coefficient is 31. Last minus 45. Okay, so while doing the synthetic division, first position we need to take 0. First position we need to take 0. And what is the factor we got? X minus 1. That means 1 is the solution. F of 1 value becomes 0 means 1 is the solution of the polynomial, as well x minus 1 is the factor of the polynomial. So 1 is the solution, I am taking 1 here. Now add these two, 1 plus 0 is 1. Now multiply each one with 1. So 1 ones are 1 and 13 plus 1 becomes 14. Again 14 ones. First 1 into 1, next 1 into 14. That 14 result you have to write here. Next 31 plus 14 becomes 45. 1 into 45 is 45. Minus 45 plus 45 becomes 0. So this 0 is nothing but remainder. And still we left 3 terms or 3 coefficients. First term 1, second term is 14, third term 45. So from the right side 45 will be the constant term, and 14 will be the x term, and 1 is the coefficient of x square term. So let us write this is x square plus 14x plus 45. And you already learned in quadratic equation chapter how to find the roots or factors of a quadratic equation by splitting the middle term, or formula we can use. Yeah, I am splitting the middle term by taking the factors of 45 as 9 5s 45, and 9 plus 5 becomes 14. So this 14 I can split like 9x plus 5x. Yeah, from first 2 terms I can take x as a common, and last 2 terms 5 common, then x plus 9 is overall factor and x plus 5. So from this I got x plus 9 and x plus 5, 2 factors. Initially I got x minus 1 is a factor. So total 3 factors. Therefore the given cubic polynomial can be expressed as x minus 1 into x plus 5 into x plus 9. This is the factorization of the cubic polynomial. Okay? Yeah, once look into it. Okay, let us go to the next concept. Right. So here, so usually we are taking the constant term and writing all the factors, right? So instead of that finding all the factors, we have one of the methods here. If the sum of the coefficient of terms, that means whether it is a cubic or biquadratic, whatever the polynomial it is, we need to check all the coefficients and add all the coefficients. Sum of coefficients becomes 0, definitely x minus 1 will be the factor. That means 1 is the solution. Sum of all its coefficients of a polynomial becomes 0, then x minus 1 is a factor. Also, we have one more factor, that is sum of the coefficients of even powers. Sum of the coefficients of even powers. That means x power 4, x power 6, x power 8, even powers coefficient we should check, and their sum as well as the constant term. So even powers coefficients as well as constant term together, the answer, and that should be equal to sum of the coefficients of odd powers. Then x plus 1 will be the factor. X plus 1 will be the factor. Okay, na? Sum of all coefficients 0, x minus 1 factor. Sum of even powers coefficients and even term, and constant term, and remaining what are else? Odd powers. Coefficients of odd powers are equal, then we can take x plus 1 is a factor. Okay? Yeah. Next. If g of x is a factor of f of x, that means g of x can be linear polynomial, biquadratic or quadratic. If g of x is factor of f of x, minus g of x also the factor of f of x. That you should remember. If g of x is factor means minus g of x also a factor. Okay, na? Right. That means that too, which highest degree term must be the positive coefficient. It is only work out when the highest degree polynomial, the highest coefficient of the polynomial must be positive. If it is negative, it won't be work out. Okay. Next, f of x is a polynomial with integral coefficients. Integrals are nothing but integers only. Integrals are nothing but integers. Okay, that means it can be positive numbers, negative numbers, 0 also. So coefficients, and the coefficient of the highest degree term is 1. Coefficient of the highest degree term is 1. Then any integer which root is fraction of the constant term. Okay, that means a polynomial with integral coefficient, all are must be integers, whether it is a positive or negative, and highest degree term must be 1. Then one of the constant term will be in fraction. This is known as integral root theorem. Okay. Yeah. So let us see f of x equals to x square minus 4x plus 3. Let us take a quadratic polynomial, and factors of constant term are 3 and 1. That means while you are taking the constant term 3, as we discussed in previous problem, we have 45 as a constant term, and we check all the factors. When we substitute in it, we will get the sufficient factors here. In same way, if you take quadratic polynomial also, we have to consider the constant term. The constant term is 3. Its factors are 1 and itself. So both will be the factors. It is work out for only sum of the quadratic polynomials, not for the all. Okay. Next, this topic, that means fifth one, x minus a, x minus b are the factors of a quadratic polynomial. Now, initially in quadratic equation chapter we discussed that if alpha beta are two roots, we can write x minus alpha and x minus beta are the factors of the polynomial. From that we can derive the quadratic equation. Same way the derivation body is given here, x square minus a plus b into x plus ab. So from this sum of roots minus b by a, product of roots is c by a, we have discussed in our earlier classes. Okay. Same way, x minus a, x minus b, x minus c are the factors of cubic polynomial. Then the required equation is k into x cube minus a plus b plus c into x square plus ab plus bc plus ca into x minus abc. While you are observing the quadratic polynomial, we will get only sum of roots and product of roots. Sum of roots and product of roots. That means alpha plus beta, alpha into beta, only two, minus b by and c by a concept. But here cubic polynomial will get sum of roots, alpha plus beta plus gamma, product of roots, alpha into beta into gamma, as well as will get sum and product of the roots combination. That means alpha beta plus beta gamma plus gamma alpha. Okay. Right. So let us see one of the example. X minus 1, x plus 2, x plus 3 are the factors of f of x. Then we need to find the polynomial. That means 3 factors are given. We need to express these 3 factors in the form of cubic polynomial. Okay. What is the cubic polynomial we discussed? That is equals to k into x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. And from the factor theorem, if x minus 1 is factor, then 1 is the root. Same way, x plus 2 is factor, minus 2 is the root. X plus 3 is the factor, minus 3 is the root. I am taking the solutions. Alpha value is 1, beta value is minus 2, and gamma value is minus 3. Let us find sum of roots. Sum of roots, nothing but alpha plus beta plus gamma. Add all of them. So alpha value 1, beta value minus 2, and the gamma value is minus 3. So add the negative integers 2 and 3 becomes minus 5. Minus 5 plus 1 becomes minus 4. So sum of roots is minus 4. Next, sum of the product of roots. Combination of both sum and product. Sum of the product of roots is nothing but alpha beta plus beta gamma plus gamma alpha. Right. So alpha value 1 and beta value minus 2. 1 into minus 2 is minus 2. Beta gamma minus 2 into 3 6. Sorry, minus 2 into minus 3 is 6. And gamma alpha minus 3 into 1 minus 3. So answer is 1. Product of roots. Only product alpha into beta into gamma. Alpha into beta into gamma. So alpha value 1, 1 into 2, minus 2, minus 2 into minus 3, 6. Substitute in the given equation. Then the required polynomial f of x equals to k into, k can be any constant. K can be any constant. Maximum we are consider the k value to 1. Okay. Now the cubic equation is x cube minus, what is the sum of roots? Sum of roots is minus 4. Here minus becomes plus 4x square. And product sum of the product of roots we got 1. So 1 into x is x minus product of roots is 6. So this is the required cubic polynomial, x cube plus 4x square plus x minus 6. Okay? Check. Right. Let us go to the next problem. Find the value of p for which polynomial 2x power 4 plus 3x cube 2px squared plus 3x plus 6 is divisible by x plus 2. How to find the p value? Now let us take the given polynomial as f of x. I am writing all the terms here. 2x power 4, 3 into x cube plus 2px square plus 3x plus 6. So this is a biquadratic polynomial, right? Because whose degree is 4. Degree 4 polynomial is called biquadratic polynomial, and here x plus 2 is a factor. Exactly divisible by x plus 2. Whenever it is exactly divisible by x plus 2, remainder 0 becomes x plus 2 is a factor and minus 2 is the solution. That means I am directly finding f of minus 2 becomes 0. That means 2 into in the place of x, substitute minus 2 power 4 plus 3 into minus 2 whole cube plus 2p into minus 2 whole square, 3 into minus 2 plus 6. Simplify this. equals to 0. 2 power 4 or minus 2 power 4. Power is even number, so minus become positive. So 2 power 4 is 16, 6 into 32. Now here minus 2 whole cube, negative term, minus 2 into 2 into 2. So that means minus 2 into minus 2 into minus 2, 3 times minus 8. Minus 8 into 3 is minus 24. Now minus 2 whole square, 4, 4 2 is 8, 8p. And this is minus 6 plus 6 equals to 0, minus plus cancel. Now 32 minus 24 is 8. 8 plus 8p equals to 0. 8p equals to minus 8 and p value minus 1. Okay? Yeah. So by using the factor theorem, I can identify the unknown value in this. P value minus 1 I got. Okay? Right. Synthetic division, find the quotient and remainder. Here, see here, find the quotient and remainder. So until then we got if a polynomial is divided by x plus 2 or x minus 1, it is mentioned that it is clearly divisible by, exactly divisible by. That means there is no remainder. But here polynomial is given by quadratic polynomial, as well as 2 is, x plus 2 is a factor. We need to identify the quotient as well as remainder. So by synthetic division, let us identify that. Okay, how to do the synthetic division? We need to take all its coefficients of the variables, even constant term also. What is the coefficient here? 3. 3 is a coefficient, and x cube coefficient is minus 1, x square coefficient is 2, and x coefficient minus 2, and the constant term is minus 4. Whenever x plus 2 is divisible, we need to take minus 2. X minus 2 is divisible by this, we have to take plus 2. Here x plus 2 is given, now we need to take minus 2. First position 0. 3 plus 0 is 3. Now minus 2 into 3 is minus 6. Minus 1 minus 6 becomes minus 7. And minus 2 into minus 7 plus 14. So this is 16 will be. Next minus 32. So nothing but minus 34 will be. So plus 68. That means 64. So last one, 64 will be the remainder. And the remaining 4 terms, nothing but their quotient. That means minus 30 for constant term, 16 is x term, 7 is x square term, and 3 x cube term. That means if a biquadratic polynomial is divided by a linear polynomial, gives the cubic polynomial. Okay? Yeah. So remainder is 64. Yeah, let us go to the next question. Right. Now, fifth degree polynomial is given. If it is divided by x minus 2, we need to identify the quotient. Okay. By doing the synthetic division as well. So let us identify here. I am writing all the coefficients here. So 2 minus 3, 5 minus 7, 3 and minus 4. So 2 will be the solution. So first position 0, 2 plus 0 is 2, 2 2 is 4, 1, again 2, 7. This will be 14 plus 7 again. And 14, 21 and 42. So what will be the remainder is 38. So 38 will be the remainder and remaining is biquadratic polynomial. So it will be 2x power 4 plus x cube plus 7x square plus 7x plus 21. Done. Okay. Right. Yeah, it is very important one. See, find the quotient and the remainder together for the biquadratic polynomial when it is divided by quadratic polynomial. So until then it is given x plus 2 or x minus 2. They are nothing but linear polynomials, right? Because only one solution we can have. But here quadratic polynomial means two solutions. We have to take two solutions first. Together we can identify that means together two coefficients or two factors we can make it involve in the synthetic division. First, given quadratic polynomial f of x I am taking. (44x square minus 76x plus 48). And let us take the quadratic polynomial g of x. It is x square minus 7x plus 12. Let us find the factors for this first. So 12 factors, 4 3s, we can take both negatives, and we can split minus 7x as minus 4x and minus 3x. That is x square minus 4x minus 3x plus 12. So simply x minus 4 and x minus 3. Both are the factors here. Now apply the synthetic division. All the coefficients of, one second, yeah, right, all the coefficients of the biquadratic polynomial, that is 1, yeah, 1 minus 11 is the x cube coefficient, and 44 minus 76 and 48. Okay, now I am applying the both roots together, 3 and 4 together I am applying here. Yeah, so for applying here I am applying the two roots here as well as. So one is 3 and second one is 4. Now for 4 we need to leave 2 zeros like this. Okay, got it now? Now 1 plus 0 is 1. Now with first 0 I am going to multiply. So 3 ones are 3, I have to write here. Minus 11 plus 3 is minus 8. Again 3 into minus 8 is minus 24. Now 4 ones are 4. Okay? Yeah, sorry, 4 into minus 8, minus 32. Yeah. So it will be minus 32. Right. So minus 56 plus 44 becomes minus 12. And with 3 12s, 36 is minus 36 here. And yeah, one second. Yeah, here 4 ones are 4. Yeah, 4 into 1, 4 we need to take here. So that is minus 20, this is 24. Now 3 24s are, yeah, 3 20 60, 3 4s 12, 72. That is plus 72. And 4 into minus 8 is minus 32. This will be 40. So nothing but 70, 108. So 108 minus 72 is 36. Okay, negative 36. Now 3 into 36 is minus 108 and 424s. So it is 80 plus 16, 96. So positive values are 48 and 96. And the negative value is minus 32, sorry, minus 108. So this will be 14 and yeah, 14, 144 minus 108, 36. Now we are applying the two solutions together. So last two must be the remainder and remaining will be the quotient. So this is nothing but x square minus 8x plus 24 will be the quotient, and the remainder is minus 36 plus 36x plus 36. This is the remainder. Okay. That's it for today, children. Thank you, and all. Have a nice day. Bye bye.